Yes, yes, recording started. You have downloaded the worksheet, right? Yes. Question number 11. Yes. Okay. We are starting from question 11 because we have discussed the chapter 1 and chapter 2 in our regular classes, and the chapter 3 we didn't discuss. So I thought when we discuss the project, we discuss the Heikel, we will start from the chapter 3. Okay, motion in 2 dimensions. Yes, 4 writing questions, right? 4 or 5. Yeah, 4 and 1 will be. I think they gave 4 questions. 15 plus 4 and 1 they will give maybe. Eh, check that EOT. 19, right? Yeah. Okay. So we will start now. Okay. So yes. No, all the questions in the Heikel. Okay, didn't skip any question. Okay, so this is our first class for the Heikel revision. I welcome you all to the class, and next 30 minutes I will explain, so you can keep your microphone muted, and after that 20 minutes we will discuss. Okay, you can ask your doubts, because now there are more students, right? So if you start asking the questions in between, then others feel like things are complicating. So we will do like that. First 30 minutes I will explain the concept, and if there is any question you can note down, and after I finish the class you can ask the question. So we are starting with projectile motion. No, starting. Okay, starting. Yeah, that time we didn't record. Okay, now you can keep quiet, okay, for the next 30 minutes, all the students. So we are discussing EOT revision. So this is our first class, part 1. So in this class we are discussing question number 11 and question number 18. Question number 11 and 18. So 18 is writing part, and these two questions are from the topic projectile motion. So we will start with the projectile motion. Projectile motion, so this one I will draw here. So here there is a football and a player is kicking the football. The player is kicking the ball, so the ball will traveling along this path. The ball is traveling along this path. Question number 11 and question number 18 from projectile motion. So first I am discussing the topic projectile motion. After that we will solve the questions. So this is the path of the ball. The path of the ball is called trajectory. And the ball is called a projectile. This ball is called projectile. The ball is called projectile. So here you can see after that player kicked the ball is in the air and there is only one force acting on the ball, that is force of gravity. So a ball or any object that is thrown into the air, thrown means it has given an initial velocity, and after that the only force acting on that object is the force of gravity, that is called projectile. So projectile, I will write here what is projectile. Projectile. So projectile has two things. Number one, it has an initial velocity. A projectile has initial velocity, which means the object is not dropped. If I drop this marker, it is not projectile. If I throw this marker, if I throw it, then it is a projectile. Why? Because when I throw, I am giving an initial velocity, and after giving the initial velocity, the object is only under force of gravity. There is not any other force acting on it. If there will be air resistance, we ignore the air resistance, neglect the air resistance. So only force acting on that object is force of gravity. Force of gravity is the only force acting on the object. So a projectile has two things. Number one, it has an initial velocity. That initial velocity, we are giving the initial velocity when the player kicked the ball. The player is giving that ball an initial velocity. After that, the only force acting on the ball is force of gravity. Then you can see here, This projectile, it is moving in the horizontal direction, means x direction. At the same time, it has a displacement in the vertical direction also. So if I draw the axis like this, x axis and y axis, so this projectile has a displacement along the x direction, and at the same time the ball has the displacement along the y direction. So a projectile motion, or a projectile has displacement along the x direction, means the horizontal direction, and displacement along the vertical direction at the same time. So we can say a projectile has both horizontal motion and vertical motion. A projectile has both horizontal motion and vertical motion. So here I will write horizontal motion, motion along the x direction, motion along the horizontal direction, and motion along the vertical direction. So vertical direction means y direction, y axis. Yes. Leave it. Just I wrote x axis, y axis. You are kicking the ball, a football, like a free kick. So the ball will follow this path, right? The path of the object or path of a projectile is called trajectory. Nothing. This path is called trajectory. The next step. So number 1. If the ball is moving in the air, when the ball is in the air, is there any force acting on the object in the x direction, means horizontal direction? So the ball is moving like this, the ball is moving. So this one I will, ignore the air resistance. Always we are ignoring the air resistance. So there is only one force acting on the object, that is force of gravity, that is acting vertically downwards. So always force is acting vertically downwards, and the magnitude of that force is always same. So I am trying to draw the force with the same length. So the only force acting on the object is force of gravity, which is acting vertically downwards. So in the horizontal direction, no force. In the vertical direction, force of gravity is acting in the downward direction. Number 2, when there is no force acting in the horizontal direction, the acceleration along the x direction, that is equal to 0. And as there is a force acting in the vertical direction, force of gravity acting in the vertical direction, acceleration along the vertical direction will be always 9.8 meter per second squared, and that acceleration will be also acting in the downward direction. Number 3. So here you can see the player is kicking the ball along this direction. So he is kicking the ball at an angle from the x direction, at an angle from the x axis. So we can say this angle, that is theta. The player is kicking the ball at an angle. So this is the initial velocity of the ball. The direction of the initial velocity is making an angle theta from the x axis, or theta with the horizontal direction. We can resolve this velocity into two components that you have already studied and you have done many times. Very clearly you know that every vector, velocity is a vector. A vector can be resolved into x component and y component. X component will be vi cos theta, and the y component of the velocity will be vi sin theta. So this vi I will write here, and here I will write vi sin theta. That is the y component, vertical component of the initial velocity. So you can see here initial velocity in the horizontal direction, initial velocity along the horizontal direction, that we will write vix, initial velocity in the x direction, that is always equal to vi cos theta. And the third point, initial velocity in the vertical direction, initial velocity along the y direction, viy, that is equal to vi sin theta. Then what about the final velocity? Final velocity, number 4, final velocity. Final velocity v final along the x direction, final velocity along the x direction, that will be also vi cos theta. In the horizontal direction, in the x direction, as acceleration is 0, that is why the horizontal velocity is always constant. So this is the direction of the force. So direction of the force and the direction of the acceleration will be same. So here I will write acceleration g, because acceleration due to gravity. And here horizontal velocity I will draw here. This is our horizontal velocity. Velocity along the x direction. The value of the horizontal velocity will be always constant, same value, because there is no acceleration. Acceleration along the horizontal direction is 0. That is why horizontal velocity of the projectile is constant throughout the motion. Horizontal velocity is constant throughout the motion. And what is the value of the horizontal velocity? That is equal to vi cos theta. That will be constant throughout the motion of the projectile. The next, what about the final velocity in the vertical direction? Final velocity in the vertical direction, v f y, final velocity along the y axis, along the vertical direction. You can see here there is an acceleration in the vertical direction. So during the upward motion, when the ball is moving up, its velocity will be decreasing. The vertical velocity will be decreasing. And when the ball is reaching the maximum height, vertical velocity will be 0. And when the ball is falling, vertical velocity will be increasing. So we can draw vertical velocity. I will draw the vertical velocity here like this. So here I will draw vertical velocity. Initially vertical velocity will be greater, then vertical velocity decreasing, and here no vertical velocity. At a maximum height, vertical velocity is 0, and when it is falling down, vertical velocity and acceleration both will be in the downward direction. Vertical velocity, then it will be increasing, vertical velocity is increasing. Vy Vy. So how to calculate the vertical velocity? We can calculate the vertical velocity if there is an acceleration. If there is acceleration, you can calculate the final velocity using the equation final velocity equal to initial velocity plus acceleration into time. Initial velocity plus acceleration into time. Here acceleration is downward, that is why we will write a minus g for acceleration due to gravitational force. So acceleration due to gravity g into t. So this initial velocity in the y direction, vy initial vi y minus gt. So this equation we will use to calculate the final velocity of the projectile. Then number 5, what is the distance traveled by this projectile? The distance traveled by the projectile is, it is starting from here and it is reaching here. So this is the distance traveled. This distance traveled we will mark delta x, distance traveled. This is also called the horizontal distance. Sometimes it is called range of the projectile, which means all means distance traveled. So we can say distance traveled, I will write delta x, that is equal to distance traveled is always velocity into time, because here you can see, here we can see the velocity is constant. So this is a uniform motion. So we will write a distance traveled is equal to its initial velocity, that is vi x into the time. Time is the total time, right? Yeah, total time. So I will write the capital T, the total time. Then here, okay, small letter t, okay, we will write small letter t down, right? Okay. No, there is no another equation. This is the only equation. Yeah, we can derive one equation, okay, that we will do after this. Okay, there is a one equation that we can derive. Okay, so this one you will see here, I will write here. Now you can see, right, number 5. Okay, so here the distance traveled along the vertical direction, that we can always calculate using this equation. You know this equation, these are equations of motion. Initial velocity in the y direction into time minus half multiplied acceleration multiplied t square, vi into t plus initial velocity into time plus half at square, right? That equation. Here acceleration is negative because it is downward, that is why we wrote minus here. What? Yeah, for y direction all kinematic equation. Yes. Range means distance traveled. Okay, for example, if I throw the marker from here to here, if it travel 10 meter, so 10 meter is called range. Okay, the distance traveled is called the range. Okay, yes. Which one? Yeah, no problem, leave it. Okay, you understand something, right? That is enough.
I see one.
Yes. Okay, now yes. How? X component along the x direction, y component along the y direction.
That's nothing now.
Okay, then next, you can go to the page number 2. Page number 2 of the worksheet. Page number 2 of the worksheet. What? Okay, you have downloaded, right? After that, I send it, I think. No? Someone can send it, okay, because all my phone is in the work. Okay. The next, you can go to the page number 2. Page number 2. Delta y is the height. See, if you kick the ball will not be moving like a free kick, for example, or if you throw this marker, it will be reaching a height, right? It will be moving the vertical distance, right? Height. Okay, so this is the ground, you are on the ground and you are throwing the ball. So this is the delta y for this time, this is the delta y for this time, this much is the delta y for this time, this much is the delta y when the ball reach here, this much distance is the delta y. Okay, delta y is the height from the ground. Yes. Yes. Yeah, okay, y component can be downward, right? So it will be the negative y direction. It will follow the y axis. Y axis can be negative or positive. See, when I throw it, this object, see here, like this, it will follow like this, right? Like this. So while falling, what is the direction of the velocity? Downward, right? When an object is falling, what is the direction of the velocity, or what is the direction of the motion? Downward. When you throw it, when it is going up, the direction of motion is upward. Okay, you will understand. Okay, when we are doing, you will understand. Then now go to the page number 2 of the worksheet. Please go to the page number 2. Okay, so can you see, I have given after that table, okay, below the table, maximum horizontal distance at what angle? 45 degree. For example, you are in a, javelin throw. What is called javelin throw, right? Like throwing like this in Olympics and all, in the athletics, not athletics, right? Okay, for example, you are throwing this marker, then it will reach the maximum distance if I throw it at an angle of 45 degree. Okay, then I will ask you some questions. Below there is a diagram given, okay, a diagram of projectile motion. So which line cover the 80 meter or near to 80, right? For example, 78, I can say. Which color line? Blue and purple, right? Okay, blue and purple. So what is the angle for the blue one? 15 degree. And what is the angle for the purple one? 75. 15 and 75, right? So I will erase this. Okay, this all we will erase. Okay, you are, this is the ground here. from the ground you are throwing something, you are throwing. So at what angle if you throw it will reach the maximum distance? At what angle it will reach maximum distance? At an angle of 45 degree, right? So if you throw an object at an angle of 45 degree, it will reach the maximum distance for a given horizontal speed. For example, this is 45 degree. You are throwing with a velocity of 5 meter per second. Okay. Then another ball you are throwing with the same velocity 5 meter per second, but at an angle of 60 degree. With the same velocity, but it will not reach there. Okay, 5 meter per second. If you throw at 5 meter per second, same speed but greater than 45 degree or less than 45 degree, greater than or less than 45 degree, it will not reach the maximum distance. Okay, that is number 1. An object will reach the maximum distance, a projectile will cover the maximum distance if you throw at an angle of 45 degree. Number 2, after that I will listen to your question. Okay, after this one I will listen to your question. Number 2, for example, we are throwing ball from here at a speed of 10 meter per second. 10 meter per second means for a constant speed, same speed. So this one, it travels 50 meter distance, 50 meter. Okay, this angle is 20 degree, 20 degree. Then what is the next angle, or what is the another angle? If I throw this ball with 10 meter per second, it will cover 50 meter distance. Another angle, not 20 degree, another angle, if we throw with the same speed, the ball will cover the same distance, the ball will travel the same distance. At what angle? What is the first angle? 20 degree, right? First angle is 20 degree. Then the question is, what is the second angle? Second angle is 90 minus 20. 90 minus 20, how much? Yeah, nobody here? 70. 90 minus 20 is 70. Okay, so if you throw at an angle of 20 degree and 70 degree, the object will cover same distance. 20 degree and 70 degree, same distance. For example, if I throw a ball at an angle of 30 degree and 90 minus 30, 90 minus 30 is 60. So for this two angle, theta and 90 minus theta, theta and 90 minus theta, same distance, same range, same horizontal distance traveled. Horizontal distance is called range. Okay, that's enough, I think. Then I gave equations. Yes, any question? What? No, see, we will get, means the object will travel same distance for same speed for two different angles. What are the two different angles? Theta and 90 minus theta, theta and 90 minus theta. If you throw a ball at 20 degree, if it travel 50 meter, okay, for 20 degree, then if you throw the ball at 70 degree, it will also travel 50 meter only for the given speed. Okay, you are throwing this marker, this object, with a speed of 10 meter per second at an angle of 20 degree, it is traveling 50 meter. Then if I throw the same marker with the same speed at an angle of 70 degree, it will travel same distance, 50 meter. The object will travel same distance for two different angles. What are the different angle? The angle and 90 minus that angle. If it is 20 degree, then 90 minus 20, 70. Okay. The next is, yes, yes, all the time you subtract from 90. Yes. Yes, yes. Okay. Then equations, equations shortcut, okay, like direct equations. So T I wrote for time of flight, H I wrote for the maximum height, and R I wrote for range, okay, maximum height and range. Which one? Yeah, in the velocity, right? Okay. Angle? Okay, wait, I will reach there. Just 1 minute. So time of flight, maximum height, and the horizontal distance, it is called range. The equation for time of flight is, what is that? 2v. V means vi, the initial velocity, sine theta divided by g. This you can remember, okay? You can remember. So how I remember this one is, then what I will do is, I will take this 2 and I will square this, v square. I will take this 2 here also, sine square theta. Here also I will use that 2g. Somehow you remember this. If you are not remembering, you will use the kinematic equation. Okay, if you are not able to remember, we can directly use the, no, equation will be same. Horizontal range will be, is there any mistake in the equation I am writing? Vi square sine, wait, sine square, sorry, sine 2 theta divided by g. These equations may not be given, will not be given. Is it given in the textbook, these equations? What? Yeah, that I don't know, but kinematic equations will be given. This question, yeah, this lesson in both writing and multiple choice, both writing and multiple choice. Yeah, h is the height, h is the height. Yes. What? Okay, see, if you cannot remember, leave it. We will use the kinematic equation, okay, to solve. Yes, if you can remember this, it will be easy for you. Yes. Angle, for example, if it is 30 degree, then it will be 2 into 30, 60. Yes, for example, if it is sine 30 square. Yes. Yes, always sine. Okay. Students, we will start the questions. Question number 3. Do you have any doubt? And you asked about the angle, right? For example, this is the velocity here, like a projectile. So it will have horizontal velocity vx and vertical velocity vy. So this is the its velocity, right? its velocity, and we divide this velocity into horizontal direction and vertical direction. So if you know the components Vx and Vy, we can calculate this angle, right? Angle theta. That is always same thing, okay? Theta equal to tan inverse y by x, right? Vy over Vx. Yeah, we will start the questions now. You can, yeah, I will explain the question, okay? Question number 3.1. An arrow is shot horizontally with a speed of 2 meter per second from the top of a tower 60 meter height. The time to reach the ground will be. So first what you can do is, when you read the question, you can draw the question, okay? You can draw the question. So how to draw the question? We will draw the question first. An arrow is shot horizontally with a speed of 2 meter per second. So here I will draw that here, the diagram. This is a building. An arrow is shot from the top of a building, from the top of this building horizontally. So initially it has only the horizontal velocity, so this arrow will be falling like this. Initially it has only the velocity in the horizontal direction, that is 20 meter per second. Vi along the x direction, that is 20 meter per second. What is Vi along the y direction? Vi along the y direction, initial velocity along the y direction, initial velocity along y direction will be equal to what? Equal to, very good, 0. Because if you throw an object in the horizontal direction, it has velocity only along the horizontal direction, and the initial velocity along the vertical direction is 0. And what is the height of the building? The height of this building is, why you don't understand, eh? Why don't understand? Listen, see, you are throwing the object in the horizontal direction, so you are giving velocity in the horizontal direction, so the object will have velocity in the horizontal direction, right? Initial velocity of a projectile, initial velocity means the person throwing, the person has to give the initial velocity, okay? Initial velocity is the velocity you are giving. For example, your name is Amina, so Amina is throwing this marker. What is the initial velocity of the marker? The velocity Amina is giving, how much velocity Amina is giving to the marker? If she is giving velocity only in the horizontal direction, it will have velocity, initial velocity only in the horizontal direction. If she is giving in between horizontal and vertical direction, means she is throwing this at an angle, then it will have velocity in the horizontal direction and in the vertical direction. Now this man, he is throwing the ball or shooting the arrow from the top of this building in the horizontal direction, so he is giving velocity only in the horizontal direction, so the arrow has initial velocity only in the horizontal direction. Why? Because he is giving in the horizontal direction only. Then vertical velocity will be obviously 0. What is the height of the building? Height of the building is 60 meter, okay? Height of the building is 60 meter, that is given in the question. We need to find the time taken to reach the ground. So I said projectile has both horizontal motion. I will write H for horizontal and V for vertical, okay? Horizontal means x axis, vertical means y axis. I have what I have. First we will write what is given in the question, okay? What is given in the question, that we will write, okay? We have initial vertical velocity, initial horizontal velocity, and the height. Okay, so I will write the equation. What do equation I have here? Here I have only one equation. In the horizontal motion I have only one equation, that is this distance traveled, range or delta x, the distance traveled in the x direction, that is equal to initial velocity in the x direction multiplied time. This is the only equation I have. This equation I can, if I want to calculate a time, I can use this equation if I know the initial velocity in the x direction, that I know 20 meter per second, and if I know this one and this. For example, if I rewrite this equation, t is equal to delta x, the distance traveled divided by initial velocity in the x direction. I know the initial velocity in the x direction, but I don't know this distance, this delta x we don't know, so we cannot use this equation. So if we cannot use the equation, this equation, we will go to the vertical motion. So in vertical motion, what do we have? We have the acceleration. Acceleration is equal to how much? Minus g, correct? Or I will write acceleration is equal to, just write 9.8. we will make the equation in the negative, minus, we will use the minus in the equation. Okay, then acceleration is 9.8, that is g, right? 9.8. Then what do I have? I have the initial velocity in the vertical direction, that is equal to 0. What else we have? I have the height is 60 meter. And what I don't have, I do not have the vertical velocity in the, means final velocity in the vertical direction, that we do not have. No. What do we need to calculate? We want to calculate the time. I want to calculate. Okay, students, see here, I told you how to use the kinematic equations many times. I was teaching this, how to use the kinematic equation. You have three kinematic equation. If there is no final velocity, which equation you will use? In most of the projectile motion question, we will always use that equation, because we know the height, right? So we will use, I will erase all these. Okay, I will erase this. So in the vertical equation, to calculate time, we will use this equation, delta y, that is equal to initial velocity in the y direction multiplied time plus half multiplied acceleration multiplied time squared. So we will use this equation. Okay, in the worksheet, what did I do is, okay, I made here minus, right? Okay, no problem. Anyway, yes, so delta y, how much is delta y? 60 meter, right? 60. Okay, equals, what is initial velocity in the vertical direction? 0. Very good. So 0 into t, 0 into time, 0, no need to write. Half multiplied, acceleration is 9.8, right? 9.8 multiplied t squared. You will use shift solve, right, students? Okay, so shift solve, you will get the answer for time. Yeah, this is MCQ. Even if it is MCQ, you need to write and solve. Okay, if you ask why did not use minus here, we will use minus here and here. Okay, because it is falling, right? So displacement in the downward direction, acceleration also in the downward direction. So we used minus, negative here I used, here also I used, and we cancelled both the negative, okay, from both sides of the equation. .49, so 3.5, right? Yes. Horizontal. Why we did not use the horizontal? Because when you use the equation, when you use one equation, in that equation there should be only one thing that you should, means you don't know, means there should be only one unknown. If there are two unknown, you cannot use that equation. So if you use this equation, time is unknown. Do you know how much distance traveled from the question? No. So one unknown to one more unknown, two unknown, right? Then you cannot use that equation, because what will you substitute for delta x? To find the time, you need to substitute for delta x. You need a value for delta x, and you need a value for the velocity. This you have. This have 20, but this one you don't have. Okay. So when there are two unknown, you cannot use. Yes. What question? Yes. Yeah, we have only this equation in the horizontal direction. Yes. Yeah. Okay. What did I write? Time of flight, right? Two v sine theta over g, right? Okay. Yeah. I will check that. Yeah. This one we will use for the, we will use it for the angular projectile motion. Okay. The other one, for this one we will use, okay, this type of motion for the angular projectile motion. Yes. Yeah, 9.8 will be always negative. Yeah, I didn't write negative because I actually wrote negative. Okay, I wrote negative here and here. Why delta y is negative? Because the object is already on the top of the building, right? So what is its displacement after its motion? It is reaching here down, right? So this much is the displacement in the downward direction, correct? Okay, so 60 meter displacement, 60 meter in the downward direction, so minus 60. Why acceleration we are taking negative? Acceleration we are taking negative because it is in the downward direction. When displacement also in the downward direction, displacement is negative, acceleration also negative. So this negative, this negative. We can cancel negative sign from both sides. If you do not cancel, no problem. You tell the calculator to do it one more time. Okay. A projectile is launched from the top of a building with an initial velocity of 30 meters per second at an angle above the horizontal. The magnitude of the velocity at t equal to 5 seconds after the launch is magnitude of the velocity after the launch, right? Yeah. Okay, that one we will solve tomorrow. Okay. We will continue tomorrow, not tomorrow, day after tomorrow, the next class. So next class we will complete this. Do you understand, students, projectile motion? Did you get any idea about projectile motion in today's class? Okay. So when we solve the question, we will solve the question slowly. Okay. When I solve the question, I will do it slowly. Okay, with taking your questions. So when we solve all the questions given in this worksheet, you will understand everything very clear. Yes. Let us see. Okay, so we will check how it is going. So if needed, we will make it. Next class, day after tomorrow. Okay. Thank you, students, for joining the class. See you on Wednesday. Okay, because I have to start grade 10 class now at 7 o'clock. So I will end the meeting. Thank you. Bye.